So in today's video, we are going to solve some questions on equal matrices. Now, what are equal matrices? Two matrices A and B are said to be equal if they have the same order or dimension. That is, they have the same number of rows and columns, and their corresponding elements are equal as well. Now, what this primarily means is that if two matrices A and B are said to be equal, then the number of rows and columns of matrix A should be equal to the number of rows and columns of matrix B. That way, their corresponding elements are also equal. So given that matrix A is equal to A, B, C, D, and matrix B is also equal to 1, 2, 3, 5. Now matrix A has 2 rows and 2 columns, and then matrix B also has 2 rows and then 2 columns. Now, since the number of rows and columns of matrix A is equal to the number of rows and columns of matrix B, we say that the two matrices A and B are equal. That way, their corresponding elements or entries are also equal. Therefore, we say that A is equal to 1, B is equal to 2, C is equal to 3, and then D is equal to 5. So that is that with equal matrices. Now let's solve a few examples. So let's take our very first example. Determine the values of X and Y. So here we have a 2 by 2 matrix multiplying a 2 by 1 matrix, and we have the resultant to be a 2 by 1 matrix. Now we are going to find the value of X and Y. Let's solve this example together. So we have the matrix 2, negative 3, negative 1, 0, multiplying the matrix X, Y, and that is equal to 2, negative 5. Now, when a 2 by 2 matrix is multiplied by a 2 by 1 matrix, the resultant matrix is also 2 by 1. So after multiplying these two matrices, we are going to get a 2 by 1 matrix, and that will be equal to 2, negative 5. Now let's multiply the two matrices on the left hand side. So we multiply row 1 of the first matrix by the column of the second matrix, and also row 2 of the first matrix by the column of the second matrix. So we have 2 times X, that is 2x, plus negative 3 times Y. And then for the second row, we have negative 1 times X plus 0 times Y. And that is equal to 2, negative 5. Now let's simplify further. So this becomes 2x, negative 3 times Y is negative 3y. We have negative 1 times X, that is negative X, and then 0 times Y is also 0. So we have this equals 2, negative 5. Now at this point, the number of rows and columns of the two matrices are equal, so we can equate their corresponding element to generate two linear equations. So we are going to have 2x minus 3y equals 2. Let's call this equation 1. And then we have negative x equals negative 5. That is equation 2. So for equation 2, we can divide through by negative 1, so that we have x to be equal to 5. Now let's put x equals 5 into equation 1 to find the value of y. So we have 2 times 5 minus 3y equals 2. That is from equation 1. 2 times 5 is 10. So we have 10 equals, we transpose 2 to the left hand side, we have negative 2, and that is equal to 3y. 10 minus 2 is 8. So we have 8 equals 3y. We divide through by 3. and then we have y to be equal to 8 over 3. Therefore, we have x to be equal to 5 and y to be equal to 8 over 3. Now let's solve some more examples. So for example 2, find the values of x and y if the matrix 3x plus 1, 7, 2x plus y, 3 is equal to the matrix 10, 3x minus y, 8, 3. Let's solve this together. Now to solve this problem, we need to generate two linear equations that contains the unknown variables x and y. And since the two matrices are equal, we can equate their corresponding elements or entries. So for the first equation, we can select 3x plus 1 equals 10, and then 2x plus y equals 8. We can as well choose 3x minus y equals 7. All you need is to generate two linear equations. So let's select 3x plus 1 equals 10. That becomes our first equation. And then we have 2x plus y equals 8. That becomes our second equation. So from equation 1, we have 3x equals, we transpose 1 to the right hand side. That becomes 10 minus 1. We have 3x equals 9. We divide through by 3 to find the value of x. And then we have x to be equal to 3. Now we are going to put x equals 3 into equation 2. So from equation 2, we have 2 times 3 plus y equals 8. 2 times 3 is 6. And then we transpose 6 to the right hand side so that we have y equals 8 minus 6, and that is equal to 2. Therefore, x is equal to 3 and y is equal to 2. Let's solve our very last example. So to example 3, given that the matrix 1, 0, 2x times 3, 2, 0, 1 is equal to 3, 2, 6, 3, we are going to find the value of x. So we have 1, 0, 2x times 3, 2, 0, 1, and that is equal to the matrix 3, 2, 6, 3. Now to find the value of x, let's multiply these two matrices. So we are going to multiply row 1 of the first matrix by column 1 and column 2 of the second matrix. Then we come to row 2 of the first matrix times column 1 and column 2 of the second matrix. So that's going to be 1 times 3 plus 0 times 0. 1 times 3 plus 0 times 0. 1 times 2 plus 0 times 1. Now to the second row, we have 2 times 3 plus x times 0, and then 2 times 2 plus x times 1. So that is equal to the matrix 3, 2, 6, 3. Now let's simplify further. 1 times 3 is 3. 0 times 0 is 0. 1 times 2 is 2. 0 times 1 is 0. 2 times 3 is 6. X times 0 is 0, so we have 6. And then 2 times 2 is 4. X times 1 is x, so we have 4 plus x, and that is equal to 3, 2, 6, 3. Now, since the two matrices have the same number of rows and same number of columns, we say that the two matrices are equal. Therefore, we can equate their corresponding entries. So to find the value of x, 4 plus x is equal to 3. So we have 4 plus x equals 3. We transpose 4 to the right hand side so that we have 3 minus 4, and that is equal to -1. Therefore, the value of x is equal to -1. So that's it for today's video. Thanks for watching and see you in my next video. Bye bye.